can start writing along. Now if you do it differentiating with respect to x, you will get the same answer, a little lengthy. So what we do is, this is a very important sum, and for this sum what we do is, we'll differentiate with respect to y. So in this sum, I'll do differentiating with respect to y. And since I differentiate with respect to y, see, this will become like this. X cos a plus y plus sine a plus y dx by dy plus sine a into minus sine a plus y is equal to 0. Okay, so u derivative of v plus v derivative of u plus sine a is a constant, it will become this. Now what I do is, therefore I will take this term, that is sine a plus y dx by dy will become, this will become, if you check carefully, this will become sine a plus y, and this term will go here, minus x cos a plus y. Now if you check carefully from this equation, if you check, the value of x will become minus sine a cos a plus y upon sine a plus y. So what we will do is, we'll substitute it. Therefore sine a plus y dx by dy is equal to sine a plus y minus x का value, this will become plus sine a cos a plus y the whole square, because there is already one cos a plus y and this cos a plus y, upon sine a plus y. And now when I solve it further, this will become sine a plus y dx by dy is equal to sine square a plus y plus sine a cos square a plus y the whole upon sine of a plus y. Now if I substitute further, if I have to solve this in the numerator, I will get if I solve this, this will become sine a plus y dx by dy. I will take sine a common. I am left with sine square a plus y plus cos square a plus y the whole upon sine a plus y. So therefore dx by dy will become sine a upon sine square a plus y Therefore, dy by dx will become sine square a plus y upon sine. And this is what we had to prove. So what we have done is, in this sum, if you do by differentiating with respect to x, you'll still get the same thing. See what we had to prove. We have to see which is the extra term that you're getting, and you'll get this x as the extra term. So what we do is, we get the value of x from the main equation, and this is what we had to prove. Now, a very important sum, a very important sum. Okay, this is the question. Huh. If under root of 1 minus x square plus under root of 1 minus y square is equal to a bracket x minus y, okay, show that dy by dx is equal to root of 1 minus y square upon root of 1 minus x square. Okay. Therefore, now what we are going to do is, you can solve it normally. Differentiate this, find dy by dx. You can do that. But if you pay attention now, what I am supposed to do is, this is constant minus square. See, remember this. Whenever you have constant minus a square term, you're either going to substitute sine theta or you'll substitute cos theta. So if I substitute x ke jagah sine theta, it will become 1 minus sine square theta, that is cos theta. And here if I substitute sine phi, so 1 minus sine square phi will become cos phi. So what I am going to do is, we'll start with now. So what we do is, I will take x is equal to sine theta. If I take x is equal to sine theta, theta will become sine inverse x. Y is equal to sine phi. Phi will become sine inverse y. Because we have the formula for 1 minus sine square theta. That is why we can take sine or cos. I can't take tan because there is no formula for 1 minus tan square theta. I can't take cot because there is no formula for 1 minus cot square theta. कौन सा रिमोट है वो? पॉज करना है। क्या बोल रहा है? कहाँ जा रहा है? कितना बजे का लेक्चर है? Now, so when I substitute, see what will this become? I am directly substituting this. So this will become so if I substitute this, see what will this become? Under root of 1 minus sine square theta plus under root of 1 minus sine square phi is equal to a into sine theta minus sine phi, because x is sine theta and y is sine phi. Now I know that the formula for the left hand side, 1 minus sine square theta will become cos theta, 1 minus sine square phi will become cos phi, and this will become a sine bracket sine theta minus sine phi. Cos c plus cos d is 2 cos c plus d by 2 cos c minus d by 2 is equal to a 2 cos c plus d by 2 sine c minus d by 2. This 2 gets cancelled, this 2 gets cancelled. Cos theta plus 5 by 2, cos theta plus 5 by 2 gets cancelled. I'll write down whatever is left. Cos theta minus 5 by 2 is equal to a sine theta minus 5 by 2. So that what is cos theta minus 5 by 2, sine theta minus 5 by 2. So in other words, what I am supposed to do is take this denominator, since that the angle is the same. I'll get therefore cos theta minus 5 by 2 upon sine theta minus 5 by 2 will become cot theta minus 5 by 2 is equal to a. Cot theta minus 5 by 2 is equal to a. I'll take cot on the other side. I'll get theta minus 5 by 2 is equal to cot inverse of a. Now cot theta is sine inverse x. Therefore, sine inverse x minus sine inverse y upon 2. Sine inverse x minus sine inverse y. I'll take the constant on the right hand side. This will become 2 cos inverse a. Now, I can differentiate this. I'll write it here. Now, if I differentiate this, I'll differentiating with respect to x. So, I'll differentiate this. Differentiating with respect to x. So, sine inverse x is 1 upon under root of 1 minus x square minus 1 upon under root of 1 minus y square dy by dx is equal to 0. Therefore, dy by dx will become under root of 1 minus y square upon under root of 1 minus x square. This is the answer, and this is what we had to prove. So what we have done is we have not done anything. Since I saw this looks like 1 minus x square and 1 minus y square, I can directly substitute the value of x as sine theta and x as sine phi. So you can do by cos also, you still get the same answer. So what is supposed to do is, this is the substitution is under root of 1 minus x square, under root of 1 minus y square. If you need this, what we have done is we have used trigonometry. We have used your formula for sin c plus sin d, sin c minus sin d, and cos c plus cos d. Okay, so these are the kind of sums that will always come. Now there is one more sum. This is the next question. Okay, x raised to y is equal to e raised to x minus y. A very important sum. X raised to y is equal to e raised to x minus y. I have to show that dy by dx is equal to log x upon 1 plus log x the whole square. Okay, a very important sum, very easy sum. So this is what we have to prove that. Okay, so now what is given to me? Given is x raised to y is equal to e raised to x minus y. What I'll do is, this is function raised to function, so I'll take log on both sides. So since I take log on both sides, this will become x raised to log of x raised to y is equal to log of e raised to x minus y. The coefficient of log becomes the power and vice versa. So this will become y log x is equal to x minus y log e. X minus y log e, we know that log e ka value is 1. So this will become y log x is equal to x minus y. Now listen carefully. Y log x equal to x minus y. Now you can directly differentiate it if you want. But let's arrange it nicely. So this will become y log x plus y is equal to x. Normal algebra, basic algebra. If I take y common, this will become log x plus 1 is equal to x. Again, therefore y is equal to x upon log x plus 1. Now I know that I am going to get 1 plus log x the whole square, because this is 0 upon v and it will be v square. So now if I differentiate this, dy by dx will become v, that is log x plus 1 into derivative of x is 1 minus x into log x का डेरिवेटिव is 1 by x, 1 का डेरिवेटिव is 0, the whole upon log x plus 1 the whole square. Now if I separate it, if I simplify this further, this will become dy by dx is equal to, I'll just open the bracket, so this will become log x plus 1 minus 1 upon log x plus 1 the whole square. This plus 1 and this minus 1 gets cancelled. Therefore, dy by dx is equal to log x upon log x plus 1 the whole square. Basic one step of differentiation. Basic algebra and logarithm का एक step use किया है. Basic algebra, we are just doing basic algebra here, u upon v. I know that since I have got this, I know that my denominator is going to be square. All I have to do is just do u upon v and get the answer. Okay. Now, this is where your implicit function gets over. The next topic would be parametric function. Now, what do you understand by parametric function? It means that x will be given in one parameter. X will be given in one parameter. Okay. Say for example, the parameter can be theta or t or m or anything. It can be theta, t, m, anything. Y will also be given in the same parameter. Same parameter. So imagine, let's take an example. Say for example, x is equal to theta. Okay. Yeah, x is equal to x is equal to t square. Y is equal to 3t. Step number 1, I will find out dx by dt, which will become 2t because I am differentiating with respect to t. dy by dt will become 3. Therefore, dy by dx is equal to, now the formula is this for parametric function, dy by dt upon dx by dt, where dx by dt is not equal to 0. It means that dy by dx is nothing but I am partially differentiating. Basically, I am using the parameter, I am finding dy by dt. Using x, I am finding dx by dt, where my denominator is not equal to 0. And since my denominator is not equal to 0, I directly substitute this. Dy by dt is 3, dx by dt is 2t, and this is my final answer. So remember this, x will be given in one parameter, y will be given in one parameter, and last mein, the crux of the question is you have to find dy by dx. And the formula for dy by dx is dy by dt upon dx by dt, where dx by dt is not equal to 0. Where dx by dt is not equal to 0. Now, say for example, we will take a sum. Now, my question is x is equal to 80 square, y is equal to 280. X is equal to 80 square, y is equal to basic sum. X is equal to 80 square, y is equal to 280. सबसे पहले step number 1, I will find dx by dt. Can you tell me what will be dx by dt? 280. Can you tell me what will be dy by dt? 2a. Now, my formula is dy by dx is equal to dy by dt upon dx by dt, where dx by dt is not equal to 0. So if I substitute here, so dy by dt will become 2a upon 280. So guys, what is the answer? 1 by 2. This is the answer. Well, what I have done is I have differentiated x with respect to one variable. This is differentiate, and they have given it's the same. ऐसा नहीं कि x और y का कुछ अलग है. They have given x with one variable, they have given y with one variable. All I have to do is I'll just have to substitute and I'll get the answer. Anybody has any doubts here? No. Anybody has any doubts? Now, बहुत simple question. But what happens when they have given a particular value of theta? When they have given a particular value of theta. So, your substitution, let's take one question first. X is equal to 3 cos t minus 2 cos cube t. यहाँ पे लिखते हैं y is equal to 3 sin t minus 2 sin cube t. Same parametric function. What I'm going to do is I'm going to normally differentiate this. This will become dx by dt is equal to minus 3 sin t minus 6 cos square t, and this will become plus sin t. If you see carefully, I can see 3 sin t common, and I will get 2 cos square t minus 1, which is nothing but 3 sin t into cos 2t. This is dx by dt. Now I'll differentiate next. dy by dt is equal to 3 cos t minus 6 sin square t cos t. Therefore, dy by dt is equal to 3 cos t 1 minus 2 sin square t, which is equal to 3 cos t into cos 2t. And now when I write dy by dx is equal to dy by dt upon dx by dt, where dx by dt is not equal to 0. And when I substitute this here, 3 cos t into cos 2t upon 3 sin t into cos 2t. ये निकला 3, ये निकला 3, ये निकला cos 2t, ये निकला cos 2t, and my final answer is cot t. All we have done is substituted with respect to x, substituted with respect to differentiated with respect to t, y also differentiated with respect to t, and finally we found out dy by dx, which is dy by dt upon dx by dt, where dx by dt is not equal to 0. Anybody has any doubts here?
Sin t is minus 3 sin t plus 6 cos square t sin t.
The derivative of cos cube t, na? Cos t the whole cube का डेरिवेटिव क्या है? 3 cos square t into minus sin t. नहीं समझा? पक्का? x raised to n and x raised to n minus 1 into derivative of x. समझा? Door by door approach. Understood? Next. Now there are some sums where they will tell you what will your substitution be when x is equal to certain value. मतलब, imagine the question is this: x is equal to a cos x is equal to theta minus sin theta, y is equal to 1 minus cos theta. ठीक है? Find dy by dx at theta is equal to pi by 4, pi by 2. So you will substitute this value at the end. If you substitute here, your answer will definitely be not defined. because you're getting dy by d theta is 0, dx by d theta is 0, everything is becoming 0, you're getting an answer as not defined. So, सबसे पहले I'll find out dx by d theta, which will become 1 minus cos theta. I'll find dy by d theta, which is sin theta. Dx by d theta is equal to 1 minus cos theta, dy by dt is equal to sin theta. Therefore, dy by dx is equal to dy by d theta upon dx by d theta, where dx by d theta is not equal to 0. And what we do is dy by d theta is sin theta upon 1 minus cos theta. Now, you can directly substitute the value here also. Not a problem. You will get the same answer. But just for practice, let's try using half angle. So the formula for sin theta is 2 sin theta by 2 cos theta by 2 upon 2 sin square theta by 2. This 2 gets cancelled. This entire sin term and sin term gets cancelled. I am left with cot theta by 2. And since I am getting cot theta by 2, कुछ सब्स्टिट्यूट नहीं करना है, cot theta by 2 आ गया. So therefore, at theta is equal to pi by 2, dy by dx is equal to cot of pi by 4. Theta is pi by 2 upon 2 is pi by 4, and cot pi by 4 is equal to 1. Same thing, final step after differentiation, you're supposed to substitute the value of theta. Anybody has any doubts here? Has everybody understood this? Anybody has any doubts?
How did you do that again? Wasn't it theta minus sin theta? I didn't understand. You just derivated it now.
Yeah.
Simply.
What is the derivative of theta with respect to theta?
Well, okay.
You're differentiating with respect to theta, no, not x. Differentiating with respect to theta, right? Both your differentiating because it's a parametric function. Okay. Now your exams will have question like this. For example, we'll take a very easy sum to start with. X is equal to a cos cube t. Okay, x is equal to a cos cube t given to you. Y is equal to a sin cube t. X is equal to a cos cube t, y is equal to a sin cube t. Prove that dy by dx is equal to y by x raised to 1 by 3. Okay, dy by dx is equal to y by x raised to 1 by 3. This is the question given to me. Dy by dx is equal to y by x raised to 1 by 3. So now, don't worry about what has been asked. सबसे पहले, never worry about what has been asked. You have to stick to the basics. You have to understand that whenever a question comes, you have to figure out कि कौन सा type है. Parametric है, implicit है, logarithmic है, double differentiation है. This looks like parametric function. So we'll treat it as parametric function in the same manner. How? I will take x is equal to a cos cube t. I know that x is a constant. Now when I do dx by dt, this will become a 3 cos square t into minus sin t, which is minus 3a cos square t sin t. This is your dx by dt. This is your dx by dt. Y is equal to a sin cube t. Therefore, dy by dt is equal to a 3 sin square t into cos t, which is dy by dt is equal to 3a sin square t cos t. This is your dy by dt. And the last substitution is dy by dx is equal to dy by dt upon dx by dt, where dx by dt is not equal to 0. So dy by dt, sorry, dy by dx will become, see this, 3a sine square t cos t upon minus 3a cos square t sin t. I think यहाँ पे ना माइनस आना चाहिए, माइनस, आई फील, विल चेक, थिंक आई हैव टू चेक द रॉन्ग क्वेश्चन. अब अच्छा, नाउ if I eliminate 3 also,
There is always multiplication on it.
okay, if I'm sorry,
All the terms are multiplication.
yeah, so this is cos square t sin t, this is sin square t cos t. Now if I check carefully, now look at this, okay, if I check carefully, I will, what I'll do is I'll eliminate one cos and one cos, I'll eliminate one sine and one sine. So see what I'm left with. I will get minus a sin t upon cos t, a cos t, ठीक है, minus a sin t upon a cos t. Anybody has any doubts here? Now we'll see now what will happen if I cut a, if I don't cut a. That's fine. Okay, चलो तुम लोगों को कट करना है तो एक कट कर देते. Let's eliminate a also. a भी निकल गया, a भी निकल गया. Now pay attention. Can you guys tell me if x is equal to a cos t, therefore what is cos t का value?
X
raised to 1 by 3.
And this will become y by a is equal raised to 1 by 3 is equal to sin t. Did you understand this? So this will become sin t का value is, minus तो बाहर ही है, this will become sin t का value is y by a upon x by a, the whole raised to
1 by 3.
which is nothing but
Y by
raised to 1 by 3.
3.
Have you guys understood this? Anybody has any doubts? So they have told you what you're supposed to prove. They have given you data. LHS is given, RHS is given. You just have to make sure your parametric function is not wrong. This is how you differentiate. You're supposed to just make sure that differentiation with respect to x, not respect to y, with respect to t है. यहाँ पे हम लोग क्या करेंगे? Parametric function है, u into v करना है, नहीं करना है, x raised to n का formula है. At the end of the day, my answer is not in terms of t. My answer is in terms of x. It means that I will have to resubstitute. Did you guys understand this? Anybody has any problem?
So in the question it's minus only, right?
Minus. In the question it's minus. Now one question I will be giving you to prove. X is equal to log of 1 plus t square. Y is equal to t minus tan inverse t. Show that dy by dx is equal to under root of e raised to x minus 1 the whole upon 2. Okay, chalo.
T square upon 1 plus. somewhere here.
Now, last topic, actually the second last topic before that. Now imagine the question is this. Okay, very easy. Just differentiate 5 raised to x with respect to log x to the base 5. Okay, the question says that differentiate first term with respect to second term. So what I'll do is let u is equal to 5 raised to x, du by dx will become 5 raised to x log 5. I'll take v is equal to log x upon log 5, and if I differentiate this, dy by dx is equal to 1 upon x log 5, and finally I will get therefore dy by dx, sorry, du by dv is equal to du by dx is du by dx upon dv by dx, where dv by dx is not equal to 0. Du by dx becomes 5 raised to x log 5 upon 1 upon x log 5. Therefore my answer is 5 raised to x log 5 the whole square into x. So what I have done is I have differentiated first term with respect to the second term. I have differentiated first term with respect to the second term. Same thing that we have done in parametric function. Here there is no parameter. We consider u, we consider v, you find out du by dx and dv by dx, and then you find du by dv. Now the next question that you do, you differentiate tan inverse of x upon root of 1 minus x square with respect to sec inverse of 1 upon 2 x square minus 1. Okay, differentiate first term with respect to second term. Now how will it go? Let u is equal to tan inverse of x under root of 1 minus x square. कुछ नहीं करना है. Take x as sin theta. Theta will become sin inverse x. Constant minus square है. Tan inverse of sin theta upon cos theta. U is equal to tan inverse of tan theta. U is equal to theta, and therefore U is equal to tan inverse x. Sorry, U is equal to sin inverse x. So du by dx will become 1 upon under root of 1 minus x square. This is your first term. Okay, this is your first term. This is your first term. Now I'll take v. V is equal to sec inverse of 1 upon 2x square minus 1. सीधा v is equal to cos inverse of 2x square minus 1. If you remember the inverse का formula, you'll get the direct answer. But if you don't, take x as cos theta. Theta is equal to cos inverse x. V is equal to cos inverse of 2 cos square theta minus 1. V is equal to cos inverse of cos 2 theta, which is equal to 2 theta. So V is equal to 2 cos inverse x, and dv by dx is equal to minus 2 upon under root of 1 minus x square. If you remember ITF ka formula, this is the direct formula for 2 cos inverse x.
We used to set inverse. And then you said if you don't remember, so you take d as cos inverse 2 cos square theta minus 1. How? I don't understand.
Sec inverse of 1 by x is cos inverse x, and cos inverse of 1 by x is sec inverse x. That's the value of v. Cos inverse of 1 by x is nothing but sec inverse x. Now when I do du by dv is equal to du by dx upon dv by dx, where dv by dx is not equal to 0. And now when I substitute, this is my du by dx, 1 upon root of 1 minus x square minus 1 upon minus 2 upon under root of 1 minus x square. This gets cancelled, therefore du by dv is equal to minus half. Have you guys understood this?
Yes.
Anybody has any doubts here? No. You solve the next question. Okay, on the same lines, guys, on the same lines. Now say for example I have u is equal to cos inverse of sin x, v is equal to tan inverse x. U is equal to cos inverse of sin x, v is equal to tan inverse x. Now see what I will do. Before simplifying, I would make it easier for you. The question is this: differentiate cos inverse of sin x sin x with respect to tan inverse x. This is the question. So what I will do is I'll take this, yes, sir. So I can directly differentiate it, but I don't want to. Now why I don't want to? Because of this reason. देखो ध्यान से. What will this become? Pi by 2 minus x. So can you tell me what is du by dx? Minus 1. Did you understand this? Simple. You did not have to do anything extra. Simple concept. And here we'll do dv by dx, which is also straightforward. And if I combine these two, I'll get du by dv. Du by dv is minus 1 upon 1 plus x square. Therefore my answer is minus of 1 plus x square. Have you guys understood this? This is the answer. Very simple sum. Acha, I'm not telling you can't differentiate it. You'll get the same answer, guys. You'll get the same answer. You'll get 1 upon under root of 1 minus sin square x into cos x. cos x upon cos x, you will get minus 1 as your answer. Okay, you get the answer as minus 1. Now, the next question, if I do this, differentiate tan inverse of under root of 1 plus x square minus 1 upon x with respect to tan inverse of 2x under root of 1 minus x square upon 1 minus 2x square. A very important sum and a very easy sum. Let's take u. U is equal to tan inverse of under root of 1 plus x square minus 1 upon x. What would be the substitution? Cos. What is the formula for 1 plus cos square theta?
Square theta by 2.
1 plus cos square theta. There is no formula. 1 plus sin square theta. There is no formula. So what next trigonometric function क्या रहेगा? Tan. Do you have the formula for 1 plus tan square theta? Yes. So x has tan theta. Therefore theta will become tan inverse x. So u will become tan inverse of under root of 1 plus tan square theta minus 1 upon tan theta. So this will become tan inverse of, what is 1 plus tan square theta? What is under root of sec square theta? Sec theta. So this will become sec theta minus 1 upon tan theta. Now if I simplify this, u will become tan inverse of, now see this will become 1 minus cos theta upon cos theta. Did you understand this? Into, what is tan theta? Sin theta upon cos theta. Any doubts here? So now this gets cancelled, this gets cancelled. Okay, just doing u only. This gets cancelled, this gets cancelled. I am left with u is equal to tan inverse of 1 minus cos theta upon sin theta. I know the formula for 1 minus cos theta. 1 minus cos theta is 2 sin square theta by 2, and sin theta is 2 sin theta by 2 cos theta by 2. ये निकला 2, ये निकला 2, ये निकला ये. What is sin theta by 2 by cos theta by 2? Tan inverse of tan theta by 2. U is equal to theta by 2. What is theta value is? Tan inverse of x, which will become tan inverse of x by 2. And if I find du by dx, it will become 1 upon 2, 1 plus x square. This is u. This is only u. Okay. I will find v. We'll find v. V is equal to tan inverse of 2x under root of 1 minus x square upon 1 minus 2x square. So take x as sin theta. So theta is equal to sin inverse x. So v will become tan inverse of 2 sin theta cos theta upon 1 minus 2 sin squared theta, which is nothing but y is equal to tan inverse of sin 2 theta upon cos 2 theta, which is nothing but tan inverse of tan 2 theta which is nothing but 2 theta, which is nothing but 2 sine inverse x. Therefore, dv by dx will become 2 upon under root of 1 minus x square. Have you guys understood this? Now I have got du by dx, I have got dv by dx. All I have to do is just substitute in the last step. So finally, du by dx, du by dv is equal to du by dx upon dv by dx, where dv by dx is not equal to 0, is equal to, this is du by dx, 1 upon 2 bracket 1 plus x square, and dv by dx is 2 upon under root of 1 minus x square, which will become root of 1 minus x square upon 4 bracket 1 plus x. Have you guys understood this?
Yes.
Anybody has any problems? Okay. So this is where your parametric function gets over, along with substitution and everything. The last topic of differentiation is double differentiation. It's the same. I'll give you a simple example. Let's start double differentiation with. Say, for example, my question is y is equal to x cube. Can you tell me what will be dy by dx? 3x square. Can you tell me what will be d square y by dx square? 6x. That's it. Double differentiation, as the same name says, you have to differentiate it twice. Nothing else. So, one question that we did in parametric function. Okay, the same question that we did in parametric function. Okay, if you remember, we had done this question. X is equal to 80 square, y is equal to 280. Okay, I am supposed to find d square y by dx square is equal to question mark. So what I'll do is, I'll find dx by dt. Dx by dt will become 280. Can you tell me what will be dy by dt? 2a. Now can you tell me what will be dy by dx? 2a upon 280. So guys, what is dy by dx, guys? 1 by t. Very good. Very nice. So now can you tell me, simple, what will be d square by dx square?
There's no extra.
Or 0. D by will become 0. No.
T is not a constant because t is here also, no?
T raised to minus 1 by 2 upon 2. Yeah.
You're differentiating with respect to x, right? When you differentiate y, you write 0. What do you write? dy by dx, right? When you differentiate y, what do you write? dy by dx, right? When you differentiate with respect to t, it becomes dx dy by dt. Now you're differentiating t with respect to x, तो क्या हो जाएगा? dt by dx. And what is dt by dx? I have dx by dt. See, dx by dt is this. So dt by dx will become 1 upon 280, which will become minus 1 upon 280 cube. This is the normal differentiation that we're doing, double differentiation. Because you're differentiating with respect to t, t ka derivative will become dt by dx. Have you guys understood this? Now, here's this question. ax square plus 2hxy plus by square is equal to 0. I have to find d square x by dx square is equal to question mark. Okay, double differentiation. ax square plus 2hxy plus by square is equal to 0. Find d square by dx square. कुछ नहीं करना है. It's a very easy question. How are we going to start with this? सबसे पहले ax square plus hxy plus hxy plus by square is equal to 0. I take x common, ax plus hy plus y common, hx plus by is equal to 0. ठीक है, ax plus hy and y common, hx plus by, ax square plus 2hxy plus by square combination. Let me see the question. ax square plus 2hxy plus by square equal to common. ठीक है, now see this. Okay, now therefore y hx plus by is equal to minus x ax plus hy. Therefore y by x will become minus ax plus hy upon hx plus dy. Have you understood what I have done? I have not differentiated anything. I have just solved till here. Why? You will come to know. Now listen to this. Pay attention. This I am going to differentiate now. Okay? Exactly here I am going to differentiate. Now this is where I am going to differentiate this. So iska derivative will become 2ax plus 2h first term into derivative of second term plus second term into derivative of first term plus 2by dy by dx is equal to 0. I can see that everywhere there is 2, so I'll divide by 2. So this will become ax plus hx dy by dx plus hy plus 2by dy by dx is equal to 0. Now I'll take all the dy by dx terms together. See, these are the two dy by dx terms together. So if I write dy by dx together, I'll be left with hx plus by. Hx plus by. See this. Hx plus by is equal to minus ax plus hy. Ax plus hy. And therefore, I have got dy by dx is equal to minus ax plus hy upon hx plus by. Guys, इसका वैल्यू क्या है एक्चुअली? y by x. This is y by x. This is y by x. Now since I've got this value as y by x, dy by dx is y by x. You can take it as a remark, you can take it as a sum. Guys, if you get your derivative as y by x, your second derivative is always going to be 0. If you get the first derivative as y by x, your second derivative will always be 0. How? If I differentiate this d square y by dx square, first term into derivative of second term minus second term into derivative of first term upon x square. Now what I'll do is I'll substitute dy by dx का value. Now if you check, dy by dx का value is y by x minus y upon x square. ये निकला x, ये निकला x. Guys, what is y minus y? My answer is 0. So अगर मेरा first derivative y by x है, मेरा second derivative हमेशा 0 होगा. If my first derivative is y by x, my second derivative will always be 0. Now, second derivative में two proof sums बहुत ज़्यादा है. X raised to m, y raised to n is equal to x plus y raised to m plus n. I have to find d square by dx square. Okay, I have to find second derivative. Too complicated to solve normally, I'll take log. So log x raised to m, y raised to n is equal to log of x plus y raised to m plus n. What is log AB, guys? Log A plus. So can I directly write this as log x raised to m plus log y raised to n is equal to log of x plus y raised to m plus n. Okay. X raised to m, y raised to n is equal to log of x plus y raised to m plus n. The power becomes the coefficient. So m log x plus n log y is equal to m plus n log x plus y. Now I'll differentiate it. So this will become m upon x plus n upon y dy by dx is equal to m plus n into log of x plus y will become 1 upon x plus y into 1 plus dy by dx. Okay, how many of you have not understood this? कुछ नहीं किया है मैंने, सिर्फ log of x plus y को first I have taken log का derivative and then x plus y का derivative. Now if I write it in a particular way, m plus n upon x plus y plus m plus n upon x plus y dy by dx. I'll take all the dy by dx term on the left hand side, non-dy by dx term on the right hand side. I'll take all the dy by dx term on the left hand side, non-dy by dx term on the right hand side. So this will become n upon y dy by dx minus m plus n upon x plus y dy by dx is equal to m plus n upon x plus y minus m by x. Okay. Now if I take dy by dx common, this will become n upon y minus m plus n upon x plus y is equal to m plus n upon x plus y minus n by x. Now if I take the LCM here, nx plus ny minus my minus ny upon y into x plus y, mx plus nx minus mx minus my upon x into x plus y. ये निकला मेरा x plus y, ये निकला मेरा x plus y, ये निकला मेरा ny, ये निकला मेरा mx. Now see what I am left with. dy by dx into nx minus my upon y is equal to nx minus my upon x. ये निकला मेरा nx minus my. So can you tell me what am I getting as dy by dx? What is dy by dx? Y by x. If dy by dx y by x, see this. Therefore d square by dx square is equal to 0. And you have to write this step, guys. Therefore you have to show that d square by dx square is equal to 0. See, I've solved the entire thing here. D square by dx square is equal to 0. So whenever your first derivative is dy by dx, the second derivative is ultimately going to be 0. Anybody has any doubts here? Has everybody understood this? Now, double differentiation. If I have to tell you, imagine the question and what we have to prove and how we have to prove and how students do it. I'm just going to show it to you. So वही हमको avoid करने का. So we'll be doing, to show you, y is equal to 3 cos log x plus 4 sin log x. ठीक है, double differentiation. No? Show that x square d square y by dx square plus x dy by dx plus y is equal to 0. show that x square d square by dx square plus x dy by dx plus y is equal to 0. Now, a lot of students, what they'll do is they'll find first derivative, they'll find second derivative, they'll substitute in the left hand side and they'll prove it as 0. Double differentiation is very easy to solve. How? We'll get the entire statement. We'll not find first, second, third derivative. We'll just get the entire statement in one line. How? Together after solving particularly. How? Y is equal to 3 cos log x plus 4 sin log x. Okay, I'll differentiate this. So dy by dx will become minus 3 sin log x upon x, that is derivative of log x, plus 4 cos log x upon x. Now, in double differentiation, if you have a denominator, take the denominator on the left hand side. In double derivative, if you have a denominator, take it on the left hand side. So this will become x dy by dx is equal to minus 3 sin log x plus 4 cos log x. Now I'll differentiate. I'll solve this by, again when I differentiate this. Now guys, I'll differentiate again. Now left hand side I will have to solve by u into v. Left hand side I'll have to solve by u into v. This is product rule. So this will become x d square y by dx square plus dy by dx into 1 is equal to minus 3 cos log x upon x minus 3 minus 4 sin log x upon x. Now I'll take the denominator on the left hand side. So this will become x square d square y by dx square plus dy by dx is equal to minus 3 cos log x plus 4 sin log x. Therefore, x square d square y by dx square plus x dy by dx is equal to minus y. Therefore, x square d square y by dx square plus x dy by dx plus y is equal to 0. Exactly the same thing that we have written. So we're not doing iska derivative, then we substitute the left hand side. No. Whatever is given, if there's a denominator, take it on the left hand side, you'll get exactly what you have been asked to prove. We have proved everything. पूरा proof कर दिया equal to 0. पार्शियल डिफरेंशिएशन किया नहीं, हम लोग ने अलग से डी स्क्वायर बाय डी स्क्वायर निकाला, डी बाय नहीं किया है. We directly differentiated this. Have you guys understood this? Anybody has any doubts here? Now, on the same lines, look at the next question. Okay, now imagine the question is this: y is equal to sine inverse x. Show that 1 minus x square d square y by dx square minus x dy by dx equal to 0. Same method. Step number 1. Y is equal to sine inverse x. Dy by dx is equal to 1 upon under root of 1 minus x square. Under root of 1 minus x square dy by dx equal to 1. We'll solve this by integration by parts. U derivative of v plus v into 1 upon 2 root of 1 minus x square into minus 2x is equal to 0. Have you guys understood this? Anybody has any doubts? Now if I arrange this, this will become under root of 1 minus x square d square y by dx square minus this 2 and this 2 gets cancelled, minus x upon under root of 1 minus x square dy by dx equal to 0. Now I'll take the LCM, and if I take the LCM, this will become 1 minus x square d square y by dx square minus x dy by dx upon under root of 1 minus x square is equal to 0. It will go on the left hand side, right hand side, sorry. 1 minus x square d square y by dx square minus x dy by dx equal to 0. Did you guys understand this? Anybody has any doubts here? So we are doing the same steps again and again and again. So last sum. Now I'm not going to give you कि क्या proof करना था. We'll just go with the flow. कि क्या पूछा? Y is equal to e raised to m cos inverse x. Okay, I'm not writing what we have to prove. Let's do double differentiation by the same method. Let's do directly. dy by dx is equal to e raised to m cos inverse x. Can you tell me what is m cos inverse x का derivative? Minus m upon x square. I'll take the denominator on the left hand side. So under root of 1 minus x square dy by dx is equal to minus m e raised to m cos inverse x. Okay. Now I'll do u into v. So 1 minus x square d square y by dx square plus dy by dx into 1 upon 2 root of 1 minus x square minus 2x is equal to minus m e raised to m cos inverse x into minus m upon under root of 1 minus x square. Have you understood this? You've got the same thing again. Again there's a denominator. So where will I take? Left hand side. तो क्या हो जाएगा बोलो? 1 minus x square d square y by dx square minus x dy by dx is equal to m square y, because this is nothing but what? This is your final answer. Under root of 1 minus x square d square by dx square minus x dy by dx is equal to m square. नहीं है ना, 1 minus x square ही है. यहाँ पे अंडर रूट है ना. I just multiplied this term here ना, तो this got cancelled and got this. This is what we had to prove. These are all very important sums. Have you guys understood this?
Yes.
So your differentiation gets over. Actually differentiation gets over. अब JE का differentiation start होगा from next lecture.
This was HSC.
This was HSC.
This is HSC.
Yeah, who have come in J.
Pause.